Good morning, everybody, and thank you for showing up first thing in the morning. This and the last sessions are always the hardest. Today we are going to talk about Azure Key Vault. It's a new service that we launched earlier this year. My name is Sumedh Barde. I'm the lead program manager for the Azure Key Vault service.
Good morning, everyone. My name is Devendra Tiwari. I am a program manager in the Azure Security Engineering, and I'll be co-presenting with Sumedh on the cool technologies we have introduced yesterday.
So before I talk about Key Vault itself, I just wanted to frame a little bit about Microsoft's key management approach in the cloud overall, because that sets the context for why we built the service. So Microsoft's cloud has multiple components to it. There is VMs that you run. There is the PaaS services like Azure Storage, HD Insight, Azure Machine Learning, and so on that you use in your application. And then there is complete off-the-shelf SaaS software that we offer, Office 365 being the premier one, CRM Online, Azure SQL, and so on. Quick show of hands on how many people or your organizations are already using SaaS services from Microsoft. It's more than half. How about those who are building applications against our PaaS services? And how many doing VMs in Azure, running your own workloads? Wow, it's a fairly even distribution between the last two. There is also two different kinds of people, obviously, who talk to the cloud. There is developers, and I mean developers in a very broad context, solution providers, anybody who builds applications. And then there are IT pros. And again, I mean this in a very, very broad context, people who don't code but use existing applications. How many of you are developers here? All right. What's your name, sir? Paul, okay. If you don't mind, can I volunteer you later for one of my slides? Thank you. How many people here are IT pros in a broad context in the sense that you deploy applications to the cloud? Awesome. And any of you are actually responsible for key management in your company? What's your name, sir? Magnus, perfect. Thank you, Paul. Magnus. And in the IT Pro segment, are there anybody in particular who are responsible for compliance and audit in your companies? Yes, sir. Can I volunteer you too? What's your name? Rob, perfect. Bob, thank you. All right, so one common problem, and which is the reason you're here, is how do I manage my keys and secrets across this plethora of services that your organization is deploying in the cloud? And that's true. Developers have the same question for apps they are building, and people who are deploying applications, ready-made applications, also have the same question, saying, oh, these applications already exist. How do I control the keys for it? So just getting into the next level of detail, this is specifically what we've heard from our customers over the last few years of building cloud services. And I would love it, as I go through these bullets, if you show a quick, just show of hands regarding how much this resonates with you specifically. Everybody, almost everybody says, I want my data encrypted at rest in the cloud. And that's the easy portion. Encryption is free. The harder challenge is, where do I throw the keys? Some people want to say, I want my encryption keys in HSMs. Quick show of hands. All right. Many people, for compliance reasons, say, well, I need to prove to my auditor that I generated the key, I rotated the key on a regular basis, I can see audit logs of my key, I am in control of the key itself. Doesn't matter where the key is. Quick show of hands. All right, more people. This is a burning problem because of laws, and many verticals need this. And then as organizations deploy more and more applications in the cloud, keys proliferate, and the people who are responsible for key management really would like it all in one place where they can control in one place who has access to the keys, when to rotate the keys, and so on. There are some customers who are in countries where laws require them to keep their keys in country, or so they think. I mean, it's not, the legislative landscape is evolving fast, so it's not always clear, but there are, in Germany and Switzerland, there is some motion towards stamping this into law. And then there are finally many people who ask us, I want my keys on premises or in dedicated HSMs. The in-country, does anybody here, is anybody here from a country that requires that? Okay, awesome. And the last two bullets. Okay, there's one. Microsoft's approach is not a one-size-fits-all. That cannot be. Every problem does need an optimized solution for it. And so here is the set of options that we have for you. Historically, we have offered, well, if you're running your own application in the cloud, you can join it to your own data center through VPN, ExpressRoute. You can use your on-premises HSMs for keys. You can use any other key manager for your keys. There's tons of them out there. So that is supported, continues to be supported. And that covers all of the applications that you're building. The applications that you're using in the cloud, like Office 365, Azure SQL, obviously you cannot change that because that's someone else's code, Microsoft's or Salesforce or whatever. People who are in these countries where they need keys in their country obviously have a much more challenging problem. They can continue to call back on premises, but that requires them to continue to have their own data center. Azure is going out on a per country basis to many countries that require this. We are in China, completely operated by a Chinese company, hands off from Microsoft. We are in Australia, which is isolated to Australian region. We are in Japan, isolated to the Japanese region. And we'll keep doing this in every country. Azure and Office 365 will go to every country that has a big enough market for this kind of requirement. And our key management story will follow suit with that. The new service that we introduced in Jan is Azure Key Vault. And that is intended to fill this gap over here. So now, the SaaS services, not all of them are integrated yet, but they are getting integrated pretty rapidly, will offer you the choice to keep your keys in a location you control, specifically a thing called an Azure Key Vault, manage them from there, and make sure that those keys are in an HSM if you so choose. And furthermore, because they are externalized to the application, you can control all those keys in one place separately from the application. You'll notice that the bottom three are a bit blank. For the encryption keys in dedicated HSMs, Microsoft doesn't have them. But if you have a need for that, come up to me later. We have partners that offer these in some locations, not all locations. And so if you have your application in Azure, you can call out to dedicated HSMs that these guys lease to you. But again, that is only available to your own application. As far as the SaaS applications is concerned, we don't make that available yet. Many people ask that. Here, there was only a handful of people who asked, and we are seeing that trend. The number of people asking this spiked up about a year ago, and then slowly has been on the wane as people realize, wow, I am actually not getting what I thought I wanted by asking for that. And furthermore, there are lots of downsides. I won't go into the details of what those are, but in the end, if we have time, I'm happy to answer what was that realization.
I think you need to point here.
All right. Apart from key management, there is another class of things that people frequently asked about. So Azure Key Vault solved that problem as well. Any developers who build applications have passwords of some kind, storage account keys of some kind, sometimes keys that they don't need to offload. They are okay having it inside the application, but they still need some safe place for that. There are SQL connection strings. There's all kinds of sensitive things. There is no hard and fast requirement typically around these that the law requires, but people just ask us, hey, is there a safe place to store this? Normally on premises, I have some USB key or something that I plug in during the deployment or something like that, but what do I do in Azure? This is one thing that is common to the previous keys as well as this. Normally, applications that you are deploying on behalf of your organizations, their keys and secrets are not yours. They are your organizations. And therefore, many people have said, is there a way to tie all access to my keys and secrets back to my Active Directory so that when a user leaves, boom, their access is revoked right away? To solve these two, again, like I said, Azure Key Vault addresses these. One thing I just threw in there, I do not want to be in the news for a silly mistake, and I'll explain why. Question so far, that was the overall context as to where Key Vault fits. I'm jumping now into how you might use Key Vault in various situations, and then getting into the details. Upfront questions? Awesome. All right, this is how the picture looks today. A developer builds an application in the cloud. It could be an application built on our PaaS platform. It could be something that you're building in your own VM in the cloud. Paul here, interestingly, a red shirt, almost a red shirt, is deploying an application in the cloud. And typically, there is not too many options on how you deploy keys and secrets with it. Some people go out of the way to build their own deployment schemes to keep them secret and hydrate them from some on-premises store. Some people just throw it out into an Azure storage account that gets access. Like, the people do all kinds of things. Many people just bake this directly into their source code. And before you know it, your entire team has access to your secrets. And in today's world of DevOps, where it's not 3 operators running the show, it's a team of 50 people all coding and deploying all at the same time, guaranteed all of these guys have access to your keys and secrets. What's worse, many people use common tools like GitHub. Just yesterday, I did a search for this begin RSA private key string on GitHub. I found, 481,000 hits. These are all keys that people have baked into their code. Now, presumably, many of these are test keys. Hopefully, many of these are test keys. But you probably heard about this case back in Jan where somebody put their S3, Amazon S3 key on GitHub, noticed the mistake, removed it in 5 minutes. Just 5 minutes. There were bots that had crept up in those 5 minutes, stolen those keys, and before he knew it, by the next day, he had like thousands of dollars in bills because people were using his Amazon S3 account and spinning up VHDs. So your secrets will proliferate if you do not take care when you're building your application. In many more places than you can even imagine. Crash dumps, hibernation files, SSL gets broken, people intercept on the wire, just all over the place. Now, let's take a step back. Let's start from scratch. If we were to build this right, how would this flow even look like? And that's exactly what we tried to do with Azure Key Vault. The first thing you would want to do is to externalize your secrets from your applications and make sure that they are not part of your source code. You deploy your secrets and keys separately somehow to some safe place. And in our context, that safe place will soon be, it is already, but it's the Azure Key Vault. You want to explicitly permission who can access those keys and secrets. Those could be applications. Those could be users in some context. I separated step 1 and 3, just implementation detail. There's a container, and then there is specific keys and secrets. Typically, people want to manage multiple things together, which is why we have a container. Then you can deploy your application any number of times, configured with the URI of the key and secret. The application does not have your keys. It just has the URI to your keys. And then when the application spins up, it is authorized by Azure to access your particular secret and key. So at runtime, the application can use a secret and keys, but they're not in your source code. They're not in your on-premises repositories. None of your other DevOps team members need to have access unless you explicitly granted them access to it. Does that make Paul happy? All right. Now, very quickly, this application needs to move into an IT run pilot in many large organizations. And the first thing you want to do here or many organizations want to do here, wait a minute, guys, developers, hands off the secrets. I don't want you to deploy these secrets. Let's move them to my volunteer just went out. Let's move those secrets to the custody of somebody who's actually responsible for key management in the organization. In this particular case, I've called it a CISO, but depending on your organization, it may be just your engineering lead, or it may be some other privileged member right down the hallway, but it's not your entire team. The flow remains exactly the same. It's just a different person managing the keys and a different person deploying the application. And both of them can do this on a completely asynchronous cycle. So the CISO can keep updating the keys every 6 months, every year, grant access, and the dev keeps deploying applications, new versions of the applications, assuming the key is out there, just for grabbing the latest one. Good key hygiene. At some point, the application moves into production, and this time, the CISO is going to say, hey, wait a minute. Keys that are used in production are even higher bar. I want to move these out to a hardware security module. For those not familiar with a hardware security module, it is electronic circuitry that is optimized for cryptographic keys and process algorithms. It's typically the HSMs that we use are tamper-proof, so they're coated with epoxy, and you try to do anything to it, they zeroize themselves immediately. This is the standard by which 19 out of 20 banks operate, of the top 20 banks. Pretty much every top organization, when it comes to keys, manage them in HSMs. So you here can provision your keys in HSMs in Azure. Again, the programmatic interface to them is the key vault interface, but the keys will be inside HSMs, will only be available via the HSM. That's number one. Number two, you will also want to manage your keys, rotate them periodically, have some kind of process around it. Number three, you likely have an auditor like Bob here who will periodically look at logs for how your keys are getting accessed. Maybe write some alerts as to, hey, wait a minute, we only run our applications from 8 a.m. to 5 p.m., and why is there suddenly an access at 2 a.m. in the night? That's not us. Hey, Microsoft, what's up? So this is the kind of things that auditors would do. So one thing you'll notice here that the application and what the developer of the application had to do did not have to change. It continues to use the exact same interface to the keys. Just the left-hand side became more and more powerful along the way. And that is the promise of Key Vault, which is to make sure that you can easily build applications that move from development to pilot to production without having to change it. Because it is so easy to spin up key vaults, they're logical constructs. You can literally deploy more applications in minutes. You can scale out your application to regions across the world. You can scale out, scale up during your Christmas spike, scale down in Jan after the Christmas spike goes away, all in minutes. And then here's one case. Is there anybody out here who develops multi-tenant applications? There's one. And increasingly, I was at RSA 2 weeks ago, and it was so common to see this phrase, customer managed keys. Every customer of a multi-tenant SaaS application these days seems to say, I want to manage the keys for that application. You can just have controlled access to my keys. And we make that easy as well. For this particular developer building a multi-tenant application, you can ask your customers saying, go provision your key vaults, go manage your keys on your own over there, just give me the URI to your keys, and I will use your keys in an audited fashion as long as you let me do that. The folks on the left, who are the applications, cannot see your keys because they only get audited access to use them. Every time they need to decrypt, they need to call into us. The folks on the left are the key owners. They manage the keys independently. They get the logs. They can, at any point, revoke access to the application. So nice segregation of church and state over here. The key vault, in this context, is the broker between the key owners and the people deploying the applications. Now, here is what caps it all, which is all access to your key vaults, whether it is users accessing or applications accessing, is anchored back to your Active Directory. That means As an organization, you can centrally revoke in one place all access to your keys. If you do not like a particular, if you need to fire a user, delete them from AD, not only do they lose access from your regular corp resources, they instantly, as in within the next hour, lose access to all key vaults that your organization has deployed. Doesn't matter which of your 50,000 employees have deployed it, you instantly lose access to all of them. If the user leaves, same thing. And then finally, Active Directory and Azure Active Directory have this relationship where you can federate back to your on-premises AD and customize authentication to the wazoo if you want. You can do two-factor, biometric, whatever you want, and all of that you inherit in terms of access to the key vault. Questions so far? All right, so just to summarize, we went over these things. Number one, we gave you HSMs. We gave you mechanisms to control the lifecycle of your keys. We gave you a way to control your keys in one place rather than scattering them throughout your applications. As Azure goes into multiple countries, Azure Key Vault will follow with Azure wherever it goes. We gave you a safe place to store your secrets. I have not gone into the details of how this works yet, but just covering the promises that we met with this particular solution. We gave you a safe place to store your passwords and SQL connection strings and all these things that are not cryptographic keys. We tied all of this back to AD so that there is one place you manage access. And we made it very easy for you to develop your application, move it to pilot, move it to production, all seamless. The application need not change. For those of you building multi-tenant applications, we gave you a way to have some separation from your own customers in terms of the key management. And then I think we already covered this. We tie all of this back to your Active Directory. Looks good? All right, lots of nods. Now, let's get into the details of what exactly are we doing. Some concepts first. What kinds of things can you store with the Key Vault service? The first concept is that of a secret. A secret is any sequence of bytes under 25 kilobytes. It could be a SQL connection string, a PFX file, that may be your SSL certificate that you want to store safely, retrieve on your front end, and then use it over there. It could be an AES encryption key, triple disk encryption key, or something that you want on your application for fast access. Sometimes you want to offload your keys, sometimes you want them on your application nodes for fast access. It could be one of those. The definition of a secret is something you store in the key vault and then are able to retrieve it back. Contrast that with a concept called key, for lack of a better imaginative word. A key is just a cryptographic key, RSA 2048 to be precise. Keys are different from secrets in the sense that they have structure. We can do more about keys. You can import keys into a key vault. You can ask us to create keys for you. Keys cannot be read back. Anytime your application needs to decrypt or sign with the key, you need to call the service, the key vault service, to decrypt or sign for you. So that's the difference between secrets and keys. Depending on how much isolation you want versus performance you want, you trade off between using the secrets path or the keys path. A key vault is simply a container for related keys. In many, many contexts, when you're deploying an application, let's say you typically have one or more storage account keys, you may have one or more SQL connection strings, you probably have one or more SSL certs, and the 7 or 8 things, you don't want to individually manage access. How about you just group them together into one keychain and manage them together? And that's what the key vault construct is for. It's the unit of access control as well. You typically grant access to an entire key vault to individual people and to applications, and they get access to all of the contents of the key vault together. If you are deploying 2 different applications and need to grant access separately, you just create 2 different key vaults and grant separate access to it. Key vaults are free, they're cheap, extremely easy to spin up. For those familiar with the Azure resource model, A key vault is an Azure resource, just like a storage account, just like a SQL DB, just like a VM. And then finally, there is the concepts of Azure subscription, which hopefully everybody here should be familiar with. It's something that you subscribe and you get a bunch of features like VMs, SQL DBs, and so on. Resource groups are groupings within a subscription of related things. So you want to deploy an application, you typically need a VM, you need a storage account, you will need a key vault now that you know about it. You may need a SQL DB. You group them into a resource group and then deploy it together, move it together wherever you want. And finally, Azure AD. Everything, whether it's users or applications, need access to key vault. And for that, they need an Azure AD identity. And so we'll quickly show what that means. This is just a visual way of visualizing where in Azure does the key vault fit. Under an Azure subscription, there are multiple resource groups. Under a resource group, there are VMs, storage accounts, and then there are key vaults. Key vaults can contain secrets, one or more keys. And one thing I have not got into yet is each secret and key can have multiple versions to it. Typically, in an encryption scenario, you want to start with one key, and the CISO wants to keep rotating the value of the key every month, every year. Applications that have used previous versions of the key for encryption need to have continued access to the previous versions. So what we have here is a model where when you overwrite that key, you're not completely overwriting it. You're just adding one more to the stack, and we have an ongoing version history. Keys are of two types. Yeah?
Do you see a key vault for each resource group?
Question is, do you need a key vault for each resource group? It is typical to have a key vault per application and a resource group per application, and therefore one key vault per resource group. You don't have to. A great example might be the gentleman over there who's building multi-tenant applications. His application is going to refer to key vaults that his customers provided to him that are not even in his resource group. Another example might be you might have a resource group spanning multiple regions. You are deploying this resource group and saying, my group consists of an application instance in East US, an application instance in West US, an application instance in North Europe. And you're going to have separate VMs, separate storage accounts, and separate key vaults for every single instance of those so that you can have all local high-performance access. And that's another case where you might have 3 or 4 key vaults in the same resource group. All right, types of keys. HSM-protected keys are keys that reside in an HSM. We use the Thales, previously called Encipher HSMs. Any keys, any operations that you do on these keys, by definition, must happen inside these HSMs because you put them inside the HSM. We do not get to read them. Software-protected keys have the exact same interface. For those of you familiar with the CAPI interface on Windows, CAPI allowed applications a way to either talk to a smart card or a TPM or to local software all through one interface. That's exactly what we have done with Key Vault here. The software-protected keys have the exact same interface as an HSM-protected keys. They are just the cryptography is performed in VMs on Azure, which are also FIPS 140-2 level 1 pending. I think in the next week or two, hopefully, we should get that validation. At rest, they are also protected with the HSMs, but at runtime, all operations happen on VMs. You would use one or the other typically for the following reasons. Software-protected keys, great for testing. You can spin them up. You don't need to ask for budget, pretty cheap. HSM-protected keys cost not much, $1 per month, but still, they cost something. And so you might want to defer that to production and use software for pilot. In many cases, the isolation provided by the software-protected keys might be good enough, and even for production, you can use a software-protected key if you want to. HSM-protected keys. What's the first thing you would do when we get breached? It's inevitable. Someday, somebody is going to get breached. That's the second thing you would do. I guess that's the second, and that's the third one. Run to the bank and get your money out, because all the banks use the exact same HSMs that we do. And if they get breached, you have much larger problems than your application in Azure. But really, I mean, these are really, really good devices that we use. These are pretty much the cornerstone for every cryptography used by every major organization. And so that is really what you want to use for your production use cases. All right. That covers the concepts in a keyword service. To use the keyword service, here are the two mechanisms we currently provide. To create a keyword, to manage a keyword, to inject keys in it, to grant access, you use Azure PowerShell. It's not in the Azure portal yet. It will be later. But for the kind of audience that typically uses keywords, Azure PowerShell or the Azure Resource Manager templates are a much more convenient mechanism typically. We also have an API, the Azure Resource Manager API for creating keywords, and the Azure Keyword API for adding keys and removing keys and doing all that. We also have a client SDK in multiple languages for both of those, Azure Resource Manager and Keyword. Once a keyword is created, to use a keyword, in many cases, you don't need to do anything. Applications are pre-integrated with it, and we'll soon show a demo of some of those applications. If you're writing your own application, then you can use the REST API directly, or you can use a client SDK that we shipped, again, for the same purpose. Authorization. So I talked about authentication initially, which is all tied to your Active Directory. The next question is, OK, the user and application needs to have an identity in AD, but how do you say which user, which application can do what? And there, the key vault owner, sets an access control list on your key vault. That access control list specifies very granularly who can do what. The who is expressed as an Azure AD identity. It could be a user. It could be an application. The which operations is actually an inclusive list of operations that identity is authorized to. For keys, that's who can create keys, who can import keys, delete them. There's a set of cryptographic operations. I ran out of space, but there's also sign and verify. There is a set of operations for secrets, which is get and set secrets. So you specify very granularly, this user has access to encrypt and decrypt with the key, but not to sign with the key. This particular application has access to get and set secrets, but not do any cryptographic operations on keys. Operations that you do are authorized for all keys in the set and all secrets in the set. If that's not your intent, then create different keywords. Once this thing has been set up, a keyword is created, a key is created, keys are created, secrets are created, you have granted access. At runtime, that user or application needs to go to Active Directory, get a token, and present it to Keyword every time they do an operation. The Keyword service will look at the token. From there, they know, oh, this is this particular user or application. Compare it against the ACL. And so it's a real-time check in the context of every single operation that you do. So with that, I will quickly get into how to create keywords. All right, so this is Azure PowerShell. Like I said, today there's two ways to do this, either through Azure PowerShell or through an API. We will have support in the portal soon. The first thing I need to do, there are some steps I've already done in this Azure PowerShell, which is downloaded the latest PowerShell module, logged into Azure, selected my subscription. So I've already done that. Now, in a particular subscription, before this demo, I had created a bunch of keywords. And I say, get Azure keyword. I get the list of keywords over here. And in this particular case, at the very top, you see the name of the vault, the resource group it is in, the specific Azure region this particular key vault is homed, which means all keys and secrets are in that particular region. And that that long URI that you see over there is one of two URIs that every key vault gets. This is one way to access it. There's a different way. We'll get to that soon. If I want to create a new key vault, I say new Azure key vault. I specify a vault name, and I'll say Ignite Demo Vault. I need to put it in a particular resource group. I would normally create this resource group ahead of time in Azure and then add this key vault to it. In the interest of time, I'll just add it to one of the existing resource groups over here that I have created. I must also specify a location I want this key vault in, which particular Azure region. And here I will say East US. It could be West US, it could be North Central US, North Europe, West Europe. There's 10 plus locations at this point. And depending on the features in a key vault you want, you choose a particular SKU. And I will, for this particular one, choose a premium SKU. All right, that was quick. You have your key vault within seconds, and this particular key vault, again, the vault name is Ignite Demo Vault. It's in East US. There is a field there, the fourth field over there, that's called a Vault URI. Remember that particular URI. That is the URI you want to give to your application to use your key vault. The tenant ID over here says, this key vault will only accept tokens from the Azure 8 Active Directory tenant that's identified by that particular GUID. Anytime a user or an application needs to access this key vault, they must first get a token from that particular Active Directory. If that Active Directory kicks you out, that's it, you lose access to this particular key vault. The default access policies over here when we create a new key vault is I, the user, Derek in this particular case, has the ability to get secrets, that is read secrets. I have the ability to create keys, delete keys, list keys, update, import keys, backup keys, restore keys. So, I was reading the permissions to keys. So I can actually get the public value of a key. I can create keys, I can delete keys, I can list keys. As far as secrets are concerned, they're usually just a get-set paradigm. The first action I would typically want to do after I create a key vault is to add secrets to it. So we default to giving this person full access to secrets. We can take that off if you want, but this is the default. All right. So far, so good. How about if I wanted to add keys to that particular key vault? For that, there is the add Azure key vault key commandlet. I specify the name of the key vault that I want to add it to. I specify the name of the key. I just supply some name that I wanted, and I'll call it Ignite Demo Key for better name. This option is if I want to import a key that I already have. If I don't specify it, it'll just create one for me. And here, this option is for specifying, do I want to create a software key or do I want to create a HSM key? In this particular case, I'll say HSM. What's happening behind the scenes is Key Vault service is asking the HSMs to say, please generate me a key. The key stays locked in the HSMs. We have our own internal ID to refer to it. we wrap that up in a larger ID, and that particular ID is baked into that second thing over there, ignite demo vault.vault.azure.net. What you'll notice is this thing is really just the vault name appended by a constant string called keys, and here is the name of the key. Earlier I mentioned that every key has versions, every secret has versions. We automatically created version 1 of it and gave it a name. The name is really just a GUID. You can refer to the latest key using just this portion of the URI and say, if I want to encrypt or decrypt with the latest key, that's the URI I pass in. If I want to decrypt with the historical version 3 of the key or something like that, I need to pass in the entire URI of this. The general guidance is when encrypting, use the latest. When decrypting, use the one that you used when encrypting. So that's an easy thing to remember. This particular key, here is the public value of it. It's in the Ignite Vault demo. The name of the key is Ignite key. Here is the version name. And here is the URI repeated just for convenience. If I want to say if I want to see the keys that are in a particular key vault, I use the get Azure key vault key commandlet, and I see a list of all the keys in this. If there were more, let me repeat this command with another one so you see what happens. I say 2 over here, and this time I will say software. There's one software key and one HSM key. I go back to get Azure key vault key. I see 2 keys now, the demo vault, which is an HSM key, and demo key 2, which is a software key. I could have set attributes saying, do not even enable this key until 3 months later. I may have prepped the key for the future. So I can set enabled, expires. All of these are JSON attributes, the standard JSON attributes. So whatever the standard has should be supported here. So what if I wanted to grant my colleague access to this particular key vault for management purposes? So I will, in this particular case, for the Ignite demo vault, I'm granting access to this particular user, Cecil, and I will grant permissions to keys as Cecil can encrypt with the keys, and that's all he can do with it. Cecil has been granted access. Now if I try to get the key vault contents again, I see 2 access control entries in it. The first access control was me, the creator of the key vault. I had quite a few rights to it. And then the second is Cecil, who has only encrypt rights to it. I can similarly grant access to applications also. Now, users obviously easily have an AAD identity. How did applications get an AAD identity? Here's how. You log into the Azure portal. You go to the Azure Active Directory tab over here. And when you click over here, you see a list of directories that you have access to. Most people should have only one, but typically some people work in multiple organizations. Some people may have test directories, so you may have multiple. In this case, I have only one. I click that directory. I go to applications. I see a list of applications registered. These are very similar to service accounts in the machine accounts in the on-premises world. Let me add one application over here and say Ignite Demo Key Vault app. And this particular flow asks a bunch of questions, not all of which are relevant in this particular flow. So here I will set it to maybe Microsoft.com. Actually, the real value does not matter in this particular thing. What matters is that it's a unique URI. The application got added. I can configure the application. At this point, this application has a name just like users have a name, and that's Ignite Demo Key Vault app. The more canonical way to refer to that application is this ID, called a client ID, also called an application ID. Just like users have passwords, applications need credentials as well. So we create a credential over here. And it's doing it. Okay, there you go. That's the particular key secret that acts as the application's password. So there is two ways to do this. This is one way, which is the easy way. There's a slightly harder way, but the more secure way, which is certificates. So you can also add certificates as your credential. That is not exposed to the GUI. You need to go through the PowerShell for that. The benefit of that flow is that you don't need to, well, let me get back. In this particular case, you need to take this, deploy this particular thing with your application so that application can then log into AD and then get access to the rest of your keys and secrets. In the case of a certificate, you didn't even have to take that step. You could ask Azure to just say, here's my certificate. Make sure that when my VM spins up, it automatically gets injected. So even your credential for your application stays away from your application deployment package. So that's what we normally recommend. All right, so that was a quick run through of how to create a key vault, give access permissions to it, add keys. Can I cover a few? Sure. So we have a few demos coming up with some applications that have been pre-integrated with Key Vault. Just wanted to cover a few concepts first. The service is currently in public preview. A number of services have already integrated with this. Azure RMS is our flagship data protection and sharing service. So if in an organization you want to share content, documents, emails securely, Azure RMS acts as a policy gateway that encrypts the document, stamps policy on a document-by-document basis. Obviously, every encryption needs a master key, and for that master key, you can put your key in a precursor to Key Vault, and we call that BYOK in RMS. SQL Server, you are able to now say, hey, SQL Server, all your databases, just encrypt them automatically. There's a database encryption key generated. The master key you can put in your own Key Vault and supply. CloudLink is a partner of ours who has created a secure VM solution. So VMs boot up. When VMs boot up, they need a key to decrypt. The master key is in a Key Vault. Devendra will shortly talk about VM BitLocker that we just announced yesterday. This is something natively built into Azure, not yet released, but we announced it. Last week, Azure Storage SDK was updated, and now encryption is built into the SDK. So you can just supply a Key Vault URI to it, and anything that you write through your SDK, it'll encrypt on the fly using your keys that were put in Key Vault. Similarly, VMs. When you're deploying VMs in Azure, every VM needs certificates of some sort. We made it very easy for you to supply your certificate in a Key Vault, point your VM to it, and now you can manage the certificate separately from the VM. When you have 25 VMs, they can all refer to the same Key Vault, same certificate. You can manage your certificate once. All 25 of them will get the latest certificate. And then finally, a couple of weeks ago, we announced Office 365 Advanced Encryption. So just like in SQL Server, Office 365 will let you encrypt your mailboxes at rest with a key, with a keychain where the master key is in your control via your own key vault. So quite a lot of applications. There's more coming very soon. We are still collecting feedback in preview from our preview customers. Lots of interest in this. We hope to go to general availability relatively soon. We do not have an SLA until we go to GA, but we are pretty much operating like we have one. I mean, we run it 24/7, monitor incidents, and so on. We are available in 6 + 2, 8, 12, 13 regions at this point. I keep losing count. In the US, Europe, Asia. Japan is an isolated region within Asia, and in Brazil. And the yellow dots are other places where Azure is, where we will be soon, where Azure Key Vault is not there yet. Any keys and key vaults that you create in a particular region stay within that particular region. Because of the way we initialize our HSMs, you have a guarantee that any keys that you generate in Europe, a US data center cannot process it, and vice versa, because those HSMs are completely cryptographically isolated. Pricing is almost throwaway. We want you to use Azure, and we made this very, very easy for you to use. This is preview pricing. GA pricing will be exactly twice of this. Any secrets that you throw in there that you read back, it's 1.5 cents for 10,000 operations. Any keys that you put in there, if they are software keys, again, the same thing, 1.5 cents for 10,000 operations. If your HSM keys, all of that applies, and you get a 50-cent per key per month. When you're done with the key, delete it, and you stop getting charged for it. That's it. Let's switch to your demo. Yeah.
Will this be a part of the Azure Pack in the future?
Absolutely. So anywhere Azure goes, this will be part of it. Now, we are not always SIM shipping, so when Azure goes in a particular region, when Azure Pack is released, we may not be, all services are not there all the time, but that's definitely the North Star. And that is, in fact, our story for how, if you want this in regions that Azure does not deploy to, Azure Pack will be the region answer.
Sumit, there is one more question.
Are you considering Russia to put your put Azure in? I cannot comment on the roadmap for Azure as a whole at this point. Devendra, do you have a public resource that we can point to?
I would suggest going to the azure.microsoft.com. That would show you the latest in the current region. And what we can do is, like offline, we can follow up and provide you about the roadmap details.
Okay. All right, Devendra.
Thank you, Sumit. Good morning once again. My name is Devendra Tiwari. And I guess we have around 15 to 16 minutes. So what we are going to do is, we'll look at how Key Vault as a service, as a key management service, is being used by the Azure security offerings, and at the same time by the Azure security or the Azure services in general. So how many of you have attended the Enabling Data Protection talk yesterday? None. Okay, so one. So that's good. So now what we'll do is we'll set the context, and then we'll show you what we announced yesterday and what we demonstrated yesterday as a Azure disk encryption solution, and how that solution uses key management or Key Vault as the underlying key story. So this is a slide which has a lot of details. So let's focus on some of the key scenarios which we're going to talk about. The first thing we're going to talk about is, let's say you have, as an Azure application owner, when you bring in your application to Azure, you could have your data stored, let's say, in storage container. Or you could have your data stored on data disk in your VHDs on the virtual machines. Or you could have your data stored in SQL Server as the relational container. Or you could be using the HD Insight service, or you could be using the Azure Backup service. So these are some of the scenarios we are looking into, which relates to how the data flows across the different applications at different locations, how the data is persisted across different containers, and then what are the protection capabilities offered by Azure, backed by Key Vault as the key management scheme. So, as I mentioned, And Sumit talked about the announcement we did yesterday, the demonstration we did yesterday about the Azure disk encryption. So we'll look into that flow as a demo, and we'll show you how you can use that service to protect your VHDs, the OS boot volume, and the data volumes on those disks. And then we'll also look into how you can use SQL Server and how you can use SQL Server with Key Vault to protect your data inside SQL Server and still get your Azure Key Vault protection to control and access the keys. I always struggle with this. So this is what we announced yesterday. Now, at a high level, a 1-minute description of what this solution is. This allows you to encrypt your OS volume and the data volumes, meaning your OS disk and the data disk, for both Windows and Linux scenarios, or for both Windows and Linux operating systems. Now, there are a few scenarios we are going to support as part of this offering, where you can bring your encrypted disk from your on-premise to Azure, and those disks will stay encrypted, and those keys will be managed inside your subscription, inside your container. Sumit demonstrated how you can create vaults, how you can create keys, manage keys, grant access. So once you have provisioned those encrypted VHDs inside Azure, you will be able to manage those keys inside Azure Key Vault under your subscription. So that's the key management integration for this solution. And then, of course, some of the threats or the value proposition of this is, yes, your content is always secured at rest. Your VMs are always protected. Now, Sumit earlier mentioned about a compromise of accounts or compromise of secrets. Now, you may not wish that, but your storage account may get compromised for whatever reason, right? Now, even if your storage account gets compromised and if your disks are encrypted and your keys are protected in your container in Key Vault, then the compromise of storage account or the loss of disk would be meaningless, meaning that theft is meaningless because the keys to the kingdom resides in the Key Vault. And what has been compromised is your storage account to get access to the encrypted VHDs. And we'll look into the demo on what exactly that compromise attack looks like and how the disk encryption solution protects you. So this is a high-level flow. I would quickly go over this. We talked about you can bring your encrypted VHDs from on-premise. You can pick up and then provision a new virtual machine for both Windows and Linux, and that stays encrypted. You can go to the Azure portal gallery, and then you can spin up a new VM and opt into the disk encryption solution. That's the second scenario. Or if you have running virtual machines or running VM in Azure, then you will have the option to turn on disk encryption for those running VMs. So those are the three scenarios we are going to cover. So at a high level, quickly, and this is the demo we are going to show you. At high level, let's say that you have running VMs in Azure, and now you want to encrypt those VMs to get the OS disk protection and the data disk protection. So what you will do is, you come in through the portal or through the APIs or PowerShell commandlet and you say, hey, I want to encrypt my disk. So you opt into that. And then there are certain parameters, configuration parameters you need to provide, including the key vault, the location URI, which Sumit demonstrated earlier. Now, once that happens, once you have opted in, then the platform is going to provision an encrypted VM for you, meaning it will take your running instance and then it will convert that running instance into an encrypted VM. And then, of course, the keys here will, whatever keys which are generated by the platform, those keys will go into your Key Vault container because you have provided the location of that Key Vault container as part of the configuration. And at the same time, you have also granted access to the Key Vault container so that the platform can write those keys. So with that, let's take a quick look at the demo. So before we look at the demo, my session expired. So let me quickly sign in into the portal. Now, what we are going to see is, I'm going to run a PowerShell commandlet, and the PowerShell commandlet, which is this one. Oh, sorry, this is not shared. Can you folks see in the back? So I'm going to run a PowerShell commandlet, and this PowerShell commandlet is saying that, hey, I want to encrypt this VM, and this is the key vault location where the platform should be putting the keys. And this is the key vault location under your control, under your custody. So we take that. Now, while that is happening, let me quickly go through the portal, and let's see if the portal has come up. Just give me 1 second. Okay, so I'm logging into the portal. So what I've done here is, I have this command, I have executed that command, and here the commandlet is giving you a message that, yes, whatever keys we are generating, those keys will go into your key vault location. Now, this is my portal, and when I go to the portal, this is the virtual machine or the VM on which I need to turn on encryption. So if you look at the disks, I have two disks here, the OS disk and the data disk. And what I have done is, by running this PowerShell commandlet, I have instructed Azure to go and turn on encryption on those OS disk and the data disk. Now, the underlying technology which we are using is, for Windows, we are using the BitLocker, which is a proven Microsoft technology for drive encryption or volume encryption. So for Windows, you will see your disks are encrypted using the BitLocker encryption. For Linux, across the different Linux distros or the SKU flavors we support, SUSE, CentOS, Ubuntu, we are going to use the dmcrypt as the underlying technology. Now, so these are in the portal, these are the disks you see, and once we have built that experience end-to-end where you can go to the portal and you can turn on disk encryption, you will be able to see the properties highlighted here saying that, yes, these volumes are protected with, with those logs appearing on those. Now, while the encryption is happening in the background, let me quickly show you by connecting to the VM. So here I am connecting to the machine. Now, you don't have to do all of this once we have built that experience end to end. You will be able to see all the status and all that through either through the portal or through the PowerShell commandlet. So while that's happening, I'm also going to prep for my another demo. It's spinning, the connection is happening. So while that is happening, let me quickly go back to the flow. So what we have seen here is, we have seen that you have enabled through this PowerShell commandlet the encryption, the disk encryption for your OS disk and the data disk, with the key being provisioned inside your the key vault container. Now we'll quickly, once it is done, then we can quickly go over the other demos which I wanted to show. Let me log on to okay. So I am on this machine. Now, this is the machine where we have enabled the disk encryption. Now what you will see here is, you will see that the lock has now started appearing on those volumes. And the reasons for that is because we have initiated the encryption operation on those OS disk and the data disk. Now the encryption operation is happening in the background, but it is initiated, it's kicked off with, and then the protection is now, you're getting the protection, the disk protection. Now, so those are the locks, the BitLocker locks. Now, you can also run this status, and then you can see that the disks are encrypted, meaning the protection is turned on those, the OS volume, and the OS volume in this case is the C volume, and the data volume in this case is the F volume. So that's basically the flow for enabling the disk encryption with the keys back in your Azure Key Vault. Now, we talked about the offline scenario, attack scenario, where let's say that now this is the location in the storage where your disks are stored, the VHDs are stored. We talked about a scenario, attack scenario, where your storage account keys are compromised, meaning the bad guys through some means have gotten hold of your storage account keys. Now in that case, because your disks are encrypted, now let's see what happens. So I take this VHD locations, because I am a bad guy now. What I have done is I have taken those the storage VHDs, and I'm copying those VHDs to my local machine. And what I'm trying to do is, being a bad guy, I have the storage account keys, I have the storage account disks, I have the storage disk, and now I'm trying to copy them into my local machine and then mount them. So I will take this just give me 1 second while the previous operation is happening. So I run that, and now what has happened is the storage, the disks are copied to my local machine, and what I am going to do now is I am going to mount that disk. Now see what has happened. Being a bad guy, having access to the storage account keys, having access to those data disk or the VHDs in storage is meaningless, because I have this protection. So we take care of the offline attack, we ensure that you get protection at rest, and wherever your VHDs and the storage, wherever your VHDs and the secrets are moved, you get that protection. So the reason for this is, having access to the storage account is not enough. The bad guy also need to have access to the key vault keys in order to be able to mount those disks or run those disks. So that's one demo wanted to show. The second demo we wanted to show is, we have another scenario we talked about where your data is stored in SQL Server, and now you want to turn on encryption, which is the transparent data encryption, and the keys are offloaded for separation of duties or isolation between the admins and the data admins and the SQL admins or the OS admins. You want to offload your keys to Key Vault, and then of course you want to meet your security and compliance commitments. So I have this VM here which is running SQL Server, and what I'm going to do is I'm going to connect to that VM. So let me quickly connect. Let me open the connection. Okay, so I'm connecting to this VM now, where what we'll do is, like, we'll quickly create a database, we'll turn on transparent data encryption, and then we will show you how you can offload your keys to Key Vault. Now we'll not get into some of the steps which Sumedh has already articulated, like you create a Key Vault container, you provision access to the principal, the AAD principal, the Azure Active Directory principal in this case. So here we assume that that's all done, and the SQL Server instance has permission to be able to access those key vault. So what I'm going to do is, this is my SQL Server, I logged into it. Okay, so you don't see a database here. So what I'm going to do is, I'm going to create a database. Now once that's done, you will see that the database will appear here, which is the TD demo database. Now the second step which I'm going to perform is, I'm going to tell SQL Server that, hey SQL Server, I want you to offload all the keys to the key vault. Now if you remember, SQL Server has this transparent data encryption capability, which we announced almost in 2008, a long time back. And then along with that, it also has the ability where it supports something called as EKM, the extensible key management, where you can take your keys and the secret certificates and offload them into to an external provider, which is Key Vault in this case. So what we are telling SQL Server here is that, hey, I have this external provider, and this connectivity is possible by virtue of the SQL Server connector, which we built and announced in January along with the Key Vault preview. So what we are doing is, we are registering that external connector with SQL Server. So we do that real quick, and then in the third step, we are setting few credentials so that the SQL Server can go and talk to the Azure Key Vault. So assuming that the Key Vault is already set by Sumedh in this case, with all the secrets and the permissions. So that has happened, and then the last step is turning on transparent data encryption. So we create a database. We have already created the database. What we are doing is, we are turning on transparent data encryption on that database. So we are saying turn on transparent data encryption. And then once the TD is turned on, as I said, the keys will always be offloaded to the Azure Key Vault in this case. Now, how do we know that the encryption is turned on? So we can go and check the status here. I will run a quick tsql statement, and it will show the encryption state 3. That means that the encryption is turned on. So this is the encryption state. My database is now protected with transparent data encryption. Nothing fancy here, because the TD functionality is already there as part of SQL Server. But what is important here is that I have integrated my system with Key Vault, and if you look here, you will see the Key Vault as a cryptographic provider. So you will see here, under the cryptographic provider, you will see the Key Vault is registered as a cryptographic provider. So that's the demo we want to cover for the Azure Disk Encryption, leveraging Key Vault as the underlying key management store, and then SQL Server using transparent data encryption and integrating with Key Vault as the underlying store. We also have demos for Linux and other stuff, but for the purpose of time, I will just restrict it to the 2 demos. Go ahead.
Are there plans to bring Key Vault TD to Azure SQL or Server?
So there was a question raised yesterday as well. Now, yes, there are definitely plans. There is a session, I believe there is a session, right now the session is going on, where the SQL guys are talking, Joachim and Jakub, they are talking about the SQL Server roadmap and the SQL Server security plans. So yes, as part of that, but I would definitely encourage you to follow up with the SQL folks on the exact timelines, but yes.
So in closing, this is what we started with, and this is what we hope we gave you. Key Vault enables you to stay in control of your secrets. The secrets are in one place, anchored to your Active Directory, protected by HSMs. In the case of keys, you can actually, even at runtime, protect them by HSMs. Key Vault does this while retaining cloud expectations, and that's the most important piece. It's easy to think in terms of deploying your own key management infrastructure, but your application, as it scales up and out in the cloud, you want your key management also to quickly scale up and out. You want to pay just for what you use. You don't want to think twice about getting a $100,000 budget from your CEO. And it scales with your app. So those two. It enables segregation of duty between the key managers in your company and the people deploying applications and data. So great, 2 sets of access controls, 2 sets of logs, cross-checking each other, no single point of compromise. It makes it easy to move your application along from development to pilot to production. And in doing all of this, we've designed it in such a way that Microsoft does not see your secrets and keys either, because it's all the root of it is in the HSMs, only comes up at runtime, and we do not, like, out of the box, build any backdoors for it. We would lose our business if we did. I hope that addressed your most common concerns and questions about key management. Looks like we are out of time, but I will be here, Devendra will be here to take questions in private. We would love your feedback on this particular session at that place. We would also love your feedback on the feature set itself at azure-key-vault@microsoft.com. That's the email address, azure-key-vault@microsoft.com. If you would like to see more features, if you have any questions that you want to ask in confidence, that's the email. Thank you.
Thank you.
Thank you very much.